Assalamu alaikum and welcome to Cambridge Chemistry channel with sarwatahmed. This is the second part of the 970 paper uh, uh, 22, question paper 22 and May June 22. Question number 5, figure 5.1 shows three reactions of 2-bromopropane CH3 CHBr CH3 this is 2-bromopropane. Reaction 1. In reaction 1, you know that bromine is substituted by the OH group, and in reaction 2, bromine is substituted by amine group, and in reaction 3, propene is formed. So these reactions are reaction 1 and reaction 2 are nucleophilic substitution, and reaction 3 is the elimination reaction. This is elimination reaction. These are the nucleophilic substitution. Also nucleophilic or SN1 reaction. SN reaction, this is also SN reaction. Because this is secondary haloalkane, so SN1 or SN2 both are possible. And you know that in primary alkane in primary haloalkane only SN2 reaction, primary haloalkane SN2, tertiary haloalkane only SN1, and the secondary haloalkane SN1 and SN2 both. Complete table 5.1 for each reaction by starting the reagent and conditions used. Identify the type of reaction that occurs. Reagent and condition. So in first reaction, CH3 CHBr and CH3. This is homolytic fission, and in next reaction CH3 CH3 carbocation is formed, and in next step OH is attacked to form CH3 CH3OH, and in CH3 CHNH2, so this is another reaction. For example, amine ammonia CH3 C Br, and this is CH3, CH3, carbocation, and now ammonia is attacked over here. Next, CH3, NH2, and CH3 plus ammonium bromide, NH4 Br is formed. So this is second reaction, and now starting the reagents and conditions used, identifying the type of reaction that occurs. So reaction 1, reagent and conditions. You know that when OH is substituted by bromine, the reagents and conditions are sodium hydroxide in ethanol, water, heat under reflux. Condition is heat under reflux, and the type of reaction is nucleophilic substitution. And in second reaction, excess ammonia in ethanolic medium, in ethanolic medium, and plus heat. Heat under pressure, and the reaction is nucleophilic substitution. And in elimination, concentrated sulfuric acid, this is elimination. A sample of 2-iodopropane reacts under the same condition as reaction 1 to produce CH3CH. This is 2-iodopropane and reacts under the same condition as reaction 1 to produce propanol, 2-propanol. Explain why iodopropane reacts at a faster rate than 2-bromopropane. You know, iodide is better leaving group because iodine is in group 7 and fluorine, chlorine, bromine and iodine. So down the group atomic radius is increased. So iodide is better leaving group due to the larger atomic radius due to uh, larger bond length. So it is easy to break the bond between carbon and iodide. Iodide is better leaving group. Iodide has, so the reason is 2 marks are there. Iodide is better leaving group. So bond length is going to increase down the group. Bond length is increased down the group and less bond energy is required to break this bond Ci. So that's why iodide is better leaving group due to the larger radius as iodide has larger radius Ci bond is weaker, hence less energy is required to break the Ci bond. So no need to write down this because 2 marks and explain why 2 iodopropane reacts at a faster rate and then 2 bromopropane. So these are the reason why iodopropane reacts at a faster rate than 2 bromopropane. Next question is figure 5.2 shows how butane 1-ol can be made from 1 bromopropane in 3 steps. This is 1, 2, 3 bromopropane and CN, this is the cyano, nitrile is formed and in nitrile it is heated with HCl and hydrolysis reaction is occur. So this CN group is hydrolyzed and the product is carboxylic acid and ammonium chloride. And in this reaction, step 3, butanoic acid is converted into alcohol group. So this is in this reaction reduction reaction occur, and in the step 3 lithium aluminium hydride tetrahydride in dry ether. Because lithium and aluminium tetrahydride is violently react with the water. So that's why um, this reagent is used, and carboxylic acid is only reduced to primary alcohol by using lithium aluminum tetrahydride. NaBH4 is not used to convert carboxylic acid into alcohol. So in this is reduction, and this is step 2 is hydrolysis, and step 1 is nucleophilic SN1 reaction. So these are the reactions, and so this is the reaction of step 2, and this is the reaction of step 3, and hydrogen is represent one atom of hydrogen from the reducing agent. And don't forget to increase the carbon chain, because cyanide group always increase the length of carbon chain. So this is from butanoic acid to butanol, and lithium aluminum tetrahydride is used in dry ether. And please, this is very important to learn that NaBH4 is used for used to reduce ketone and aldehyde, but not to reduce carboxylic acid to alcohol. Question number 6 is the question number 6. Z is a molecule which contains the element carbon, hydrogen and oxygen only. Z contains only alkene and carboxylic functional group. Complete table 6.1 by describing observations that occur when two different reagents are added to separate samples of Z. Bromine is added, so observation, if there is observation that occur when two different reagents are added to separate sample of Z is molecule contain only alkene. So this is the bromine when added to, this is the test of alkene, that when bromine is added to alkene, it decolorizes the bromine. So decolorizes like orange brown to colorless. And when sodium carbonate is added, Z contains only alkene and carboxylic functional group, and sodium carbonate, because carboxyl group is there, is present in Z. So when sodium carbonate react with the Z, effervescence of carbon dioxide. Are produced. Table 6.2 shows the percentage biomass of each element present in. So this is the using the data in table 6 demonstrate that the empirical formula is CHO. So carbon, H, oxygen. So first write on mass 41.38, 3.45, 55.17. So AR dividing by relative atomic mass 12, 1 and 16. Now mole will be 3.45, 3.45 and 3.45. So the ratio is 1:1:1. So the formula is CHO. Six point one shows the mass of spectrum Z and relative abundance is 45, 71, 116. Deduce the molecular formula Z. Explain your answer by referring to the molecular ion peak in figure. Empirical formula is 29, MR is 116. So N is equal to 116 divided by 29 is equal to 4. So the molecular formula will be CHO into 4. The formula is C4H4O4. Used to suggest the formula of the fragment with Me at 45 and 71. So this is the C4H4O mean OH, C double bond O, CH double bond CH and C double bond O. So if we COH, we know that this is the 45 and the rest is 71. This is equal to 71. So this is COOH, this is C3, H2, O2. So this is a structure of Z using relevant information from table 6.1 B and C. So this is the structural formula. So this is all about of question number 6. Hope you will understand this video. If you like this video, please subscribe the channel and share this video with others.